Okay, welcome. In this short video lecture, we discuss about the concept of quantum numbers as the atoms, atomic spectrum, Bohr's theory discuss about the electron, which is considered as a particle nature. Quantum numbers are nothing but these are set of four numbers which explains, describes the unique position, energy of electron present in the atom. So very simply we can define the quantum numbers, that is a set of four numbers which explain the unique position and energy level of electron present in the atom. So this is the definition of quantum number. Quantum number also specifies the size, shape and orientation of electrons in the orbit. Okay, so first it explains the position and energy. Second, it explains the size of electron. Third, it explains shape and orientation. And fourth important, it explains direction of spin of electron. Spin, how it is spinning. So no doubt there are total four type of quantum numbers and we discuss one by one. Now the first quantum number is the principal quantum number. Okay, it is denoted by a letter small n. So principal quantum number is denoted by the letter n. It explains the main energy level or cell of the electron. Okay, it also determines the size and energy of the orbital, and it explained by the values, that is whole numbers. N is always equal to 1 2 3 4 in this manner. So n is equal to 1 is the orbit or electron present in the first energy level. In the same manner, n is equal to 2 is the second energy level, n is equal to 3 is the third energy level. So very simply, principal quantum number is defined as the quantum number which explain the main energy level or cell of the electron and determines the size of orbital denoted by letter n. N is equal to the whole numbers like 1 2 3 4 etc. So the particularly Energy level is explained by principal quantum number. Second thing, those orbital energy level or energy of orbital is present far away from nucleus. It is considered as higher energy level orbit having n is equal to higher number. That is, suppose one electron present in the orbit having n is equal to 1 and another electron present in the atom having energy level n is equal to 3. That is, n is equal to 3 is the principal quantum number higher and it is having higher energy level. Is it clear? So principal quantum number is represented by the letter n, and n is equal to always 1, 2, 3, 4. It explains the energy level of various orbitals. Now we moving towards a second quantum number. Second quantum number is the azimuthal quantum number. It is also called as angular momentum quantum number. It is denoted by the letter L. It is denoted by letter L, small l. Now, second quantum number, that is azimuthal quantum number, always describes the shape of orbital. What is the shape? It is explained by azimuthal quantum number, and the azimuthal quantum number always depends on each value of corresponding subcell. Now suppose, what are the azimuthal quantum number? L, that is L is always equal to different shapes of orbitals, that is S orbital which is having spherical shape, P orbital which is having dumbbell shaped, D orbital which is having another orientation, and F orbital is having different orientation. Now see the shape of these orbital, that is azimuthal quantum numbers. Okay, S orbital is having quantum number 0, that is azimuthal quantum number, which is having spherical shape. P orbital is having azimuthal quantum number 1. D orbital is having azimuthal quantum number 2. F orbital is having azimuthal quantum number 3. 1, 2, 3. Okay. So these are the shapes which are showing by these quantum numbers known as azimuthal quantum number. That explain the shape of the orbitals. Now next one, okay, you understood that one. Then third one is the magnetic quantum number. Now this magnetic quantum number is denoted by M1. It describes the orientation of orbital in space. Orientation of orbitals in space in the manner that, for example, we are aware about p orbitals, and these p orbitals are having three different orientations. Now how these are the three different orientation? That is, whenever p orbital, no doubt it is having dumbbell shape, oriented on x-axis, then it is called as px. If it is oriented in y-axis, py, and if it is oriented in z-axis, on z-axis, then it is called as a pz. So this shows the orientation of orbital, that is called as a magnetic quantum number. If done, then magnetic quantum number, it shows orientation. And fourth one is the spin quantum number, that is S. It stands for S, ms, spin quantum number. Spin quantum number is nothing but it describes the direction of spin of electrons, whether if it is spinning in a clockwise direction, it is denoted as plus one half. If it is rotated in anti-clockwise, it is known as a minus one half. So the spin quantum number is denoted by letter S. It shows the direction of spinning of electron, rotation of electrons, whether it is present in a clockwise direction or anti-clockwise direction. So it is known as a spin quantum number. So this is about the spin quantum number, and their rotations are observed clockwise or anti-clockwise. We again repeat slowly, that is, what are the four quantum numbers and how they are explained. Okay, one by one. Okay. No doubt quantum numbers are the four sets of numbers which explain the energy level of atomic orbitals, shape of atomic orbital, size of atomic orbital, and orientation of atomic orbital. And it also explains the direction of spin. So these are the quantum numbers which explain these four properties. Now, principal quantum number is the first quantum number, which is denoted by a letter small n. It explains the main energy level or shell of electrons. It also determines the size of orbital, that is, orbital which is present close to nucleus is having smaller size, while the atomic orbital present far away from the nucleus, its atomic principal quantum number increases, and no doubt it is having always higher energy. Principal quantum numbers are the whole numbers, that is 1, 2, 3, 4, and it is never be 0. So it is explained by principal quantum number. Second quantum number is the azimuthal quantum number, denoted by the letter L. It describes the shape of various orbitals, that is, each value corresponds to subshell. S orbital is having spherical shape, p orbital is having dumbbell shaped, d orbital is having specific shape along with two axes, and f orbital. Then magnetic quantum number explain the orientation of orbital in the space, and it is denoted by I, letter I, small I. For example, p orbital is having three different orientation, px, py, and pz. And last quantum number is the spin quantum number. It describes the spinning orientation of electron, whether it is rotated in a clockwise direction or anti-clockwise direction, it is shown by, if it is clockwise direction it is a plus 1/2, it is anti-clockwise direction it is minus 1/2. So these are the total four quantum numbers which we have observed, which gives the explanation regarding position, size, shape, orientation, energy level of each electron present in the atom. Remember that no any two electrons are having same all four quantum numbers. This is very important statement. That is, no any two electrons present in the atom are having all four quantum numbers same, and this is a specific quantum number property. Okay, thank you.